Now here we will come to few more laws, but here we will learn the laws with regards to complements. Now we are all aware of the definition of complement by now. Let's come to the first law, and that is complement laws. What is the first law? A union A dashed is equals to U. By Venn diagram again I'll try to show because it's the easiest way you can understand. This is A and this part is A dashed. If you combine these two sets A and A dashed, will not you get the entire set U? So this part is proved. A intersection A dashed. This is A and this is A dashed. Do they have any intersection between them? They are disjoint sets, so obviously it will be phi. And intersection of two disjoint sets is equals to phi. You have already learnt. I have given you the recap part. Coming to the second law, and it's very important, very, very important. De Morgan's laws. What is the first law? A union B whole complement is equals to A complement intersection B complement. And the second law, A intersection B whole complement is equals to A complement union B complement. Let's come to the first law of De Morgan's law. Number 2, the first one I'll show. We can easily prove with two sets because A and B are two sets given. These are the universal sets. And these are the sets A, B, A, B. Look very carefully. A union B dashed. This part is A union B. Leaving this part is A union B dashed. So this is the LHS part. Now let's look to the RHS part. A dashed, that means A complement intersection B complement. What is A complement? Leaving A, this much part is A complement. Intersection B complement. Intersection means opposite stroke we have to put. B complement. B complement means leaving B whatever part is there. Let's cover with different stroke. Now which part, as because intersection is there in between, we have to check out for the common shaded part. Look carefully, leaving this much part has got shaded 2 times. That is exactly equals to A union B complement. So isn't it matching with the LHS part? Yes. So we are getting LHS is equals to the RHS part. Henceforth, the first one is proved easily. With the same procedure, I will request you to prove the second one as well. If you have any doubts in proving it, then please write me in the comment section. I'll get back to you. Now coming to the third law, that is law of double complementation. Double means 2 times you are complementing. A complement and again complement of A complement will be equals to A. How we can show it? If you are taking this set as A complement is this and A complement. Now this part complement is what? This part only. That is equals to A. That is exactly equals to A. So therefore, this part is also proved by Venn diagram method. Next law, complement of phi and U. Phi dashed equals to U. What is phi? Can you tell me? Phi is empty set. We have learned that phi is empty set. If phi is empty, then obviously phi dashed will be full. Opposite of phi. Complement means what? Opposite. If phi is empty, then phi dashed must be full. And full set means it's U. So therefore, this is U. Again, U dashed equals to phi. U means what? U means universal set. That means it is full, U is full. Now U is full, so what about U dashed? Obviously, U dashed will be empty then. If U is full, U dashed will be empty. An empty set means it's equal to 5. So 5 will be empty. So therefore, these two laws are again proved by this Venn diagram method. Now coming to a new part, and that is cardinal number. What is cardinal number? Cardinal number, from the name itself you can understand it's a number. Let's take it as small n. So n, the number of elements in a set, is called cardinal numbers. You have to count the number of elements. So just the number of elements of any set is called the cardinal number. Like in this example, A is having 5 elements. 1, 2, 3, 4, 5. So n of A will be equals to 5 since A has 5 elements. Now there are few cardinal properties of sets, just for 2 sets and for 3 sets. So we will look to the 2 sets first. When there are 2 sets, then this formula will be practiced over here. So n of A union B will be equals to n of A. This is the formula. N of A union B means number of elements in A union B. That is equals to, the formula goes as n of A, that is number of elements of A, plus n of B, that is number of elements of B, minus n of A intersection B. Why minus n of A intersection B? Because while you do n of A and n of B, 2 times A intersection B is counted. When you do n of A and n of B, 2 times A intersection B gets counted. So you are subtracting 1 n of A intersection B. So this is the formula of cardinal number. When it's a question of cardinal number for 2 sets, this is one of the formulas. Now this is for joint sets. But when there is a question of disjoint set, suppose this is A set and this is B set, that is, it is disjoint. And you know, for disjoint set, there are no intersection between them. So this intersection will not be there in the question. So for disjoint set, the formula will be n of A union B will be equals to n of A plus n of B, because n of A intersection B will not be there in that question. So this is the formula for 2 sets. Now we will come for 3 sets. Now when you talk about 3 sets, then cardinal number of n of A union B union C is equals to n of A union B union C, that will be equals to n of A, that means cardinal number of set A, plus n of B plus n of C. Now when you are taking n of A, n of B, n of C, these many things are getting repeated 2 times. So therefore you have to subtract 1 at a time. So first A and B taken together, A intersection B, n of A intersection B, first you have to subtract. Then you have to subtract B and C, that is n of B intersection C. And again you have to subtract n of C intersection A. Now while subtracting these 3, you are subtracting the middle part also. But the middle part is also essential for n of A union B union C. So therefore, at last you have to add n of A intersection B intersection C. So here comes the formula for cardinal properties of sets. This is for 2 sets and this is for 3 sets. In the next video, I will come with the probable sums of sets.